We're going to go into now finding volume of a function rotated around an axis. We'll talk about one being rotated around the x-axis first. So if you look at this graph on the left here, this function, quantity x minus 1 squared plus 1. So parabola shifted over to the right one and up one. We want to rotate this around the x-axis. Well, the distance, as you flip them, you're going to make perfect disks, perfect circles, essentially. And the radius is going to be the distance from the x-axis to the function. So like this list here, this is r. Let's do a little better r. It's not much better. Okay. So that's r, and r changes as it goes from the point -1 to 3. So this over here is our formula for finding volume. We take the integral of the area and integrate it over the 2 points, or that interval. Well, area of a circle is pi r squared. So that's what the area of each disk is. So therefore, we simply need to take, there's pi, and multiply it by whatever our function, the height over our x-axis is, and we're going to actually square that. So a couple rules. First, we need to let our function of f of x be continuous in order to do this in the first place, and non-negative. So the entire function has to be at or above 0. All right, so to calculate the volume, we simply use this formula down here. We can do this as well going around the y-axis. We would have to tilt everything, so we'd have to have a domain for y-axis. We would need the domain to be 0 to, whatever, 0 to b, I guess. So you could pick your a above 0, that's fine, but it can't be below 0. So your entire function would have to be to the right of the y-axis, or it could touch the y-axis. And the other thing we would change is we would evaluate, use volume is equal to f at b, f at a, and then pi, and then the function with respect to y. All right, at any rate, let's put this to practice for a problem here. So first we need to graph this. Let's graph this region, and then we'll see what we can do with it. So they give us 3 bounds. X plus y equals 8. Well, 1, 2, 3, 4, 5, 6, 7, 8. Point there. Point there, and it's got to be in the first quadrant. So x equals 0 and y equals 0. So we should probably just connect these. Again, that line x plus y equals 8 goes on forever both ways, but the area that we're looking at is in here. All right. And we need to rotate this around the x-axis, and we'll use that disk method. All right, well, in this case, we're going to evaluate our integral here, or our interval here will be from 0 to 8. And our top function, our f of x, will equal, so this one here is y is equal to 8 minus x. So this will be f of x is 8 minus x. That's the one on top. And on the bottom, so our g of x equals 0. So just the function y equals 0. So we're going to use this formula here. Our volume is equal to the interval that goes from 0 to 8 of pi, which can go out front, but I'm going to leave it in the formula for right now. I'll move it in a second. And our f of x, the g of x is of note if we're going to try something else. I guess we don't need that on this, so let's just get rid of this. We're not looking for between two curves. We're always looking at the x-axis. So we're just looking for f of x here. And that is going to be 8 minus x quantity squared. And then we evaluate with respect to x. So I'm going to do a simple u substitution here. U will be equal to 8 minus x. That means our du is equal to negative dx. So it will be negative pi u squared du. Because we don't have a negative there. All right, so when we integrate that, we're going to take, it'll be u cubed over 3. And then replacing the u and putting the actual values in, so that will be 8 minus x cubed over 3, evaluated from 0 to 8. We evaluated at 8 first, so negative pi, and then we can just take this out here. So at 8, it will be 8 minus 8 cubed over 3. Evaluating to 0 will be 8 minus 0 cubed over 3. So that's negative pi. This first part is 0, so we're left with 8 cubed, which is 512. So negative 512 over 3. That means our volume equals positive, because we have two negatives, 512 over 3 pi.